Alright, so I'm doing a quick video just to get our spacing and where everybody's place is in line and blah blah blah. So anyway, that's the introduction slide, right? That's required. Then we have our own slide, right? And then let's see, the next slide. No one ever put their name on this slide. So I don't know whose it is. This is Abdul Rahman's slide, problem description. And all these slides are 10 seconds long and they'll be adjusted afterwards. This slide looks like Abdul Rahman again. Alright, this is Elisa. Okay, this is AJ. This is Fadi. This is Kush. It's going to go over the subsystems. This is my section, and I'll have a video coming up right after this. Here is the final prototype that was approved for production. First subsystem I like to go over is the hinge assembly, which allows the concrete breaker to be folded in half to be reduced from 10 feet to 5 feet sections. A simple clamp style latch will release. And then we have a standard 3.5-inch door hinge on the back side, and the whole assembly folds in half as demonstrated. It's a little bit of a gapping distance because of the pulley, but we don't think that should be an issue in order to transport the device. Another sub-assembly I like to go over is a cantilever beam. Here we have 2 pulleys, some 2x4s. Move one of the 2x4s so we can see the screws that go in. Calculated shear forces on these screws are about 3,000 psi, and that's without the support 2x4 on the bottom, which are held up by 4 screws. Pull-out forces for the wood using pine is about 110 pounds per screw. We don't know what the shear force would be for shearing wood. The bottom of the post has the flange that connects 4 half-inch bolts, an 18-inch pipe with a T-connector, a 36-inch pipe for the backside, an elbow connector, and then a 6-inch pipe to stabilize. Because of the flange that connects to the post, we had to think of a way to have the rods lean forward, and it actually helped out because it provides better stability. Alright, so looking back at the pulley system, we just have these 2 pulleys that line up and they allow cable to pass over them. Here we have a simulated rope. Having all the mates done was proving to be a little bit complicated, so we just did a quick sketch. And now for the way it works. So you pull on the handle, the weight comes up, and you release the handle, and the weight should come flying down with gravity. Now, the handle's shape and size can be changed. We can make something lighter and more ergonomic. But for the most part, it's just a very basic operation. Very cool, very cool. Drop it. Drop it. Boom! Explosion. Alright, now this is a Lisa slide for the final performance. I'm gonna run it for 10 seconds. Then we have a conclusion. And then the final slide will be recommendations for next steps. And that'll be a wrap. Probably put the end slide or some bullshit like that. I don't know. Up to you guys.